Okay, so the directions to the back page say, find the inverse functions of the following. We've done plenty of finding inverse. If we look at number 1, it's a log problem. So the inverse of a log, my final answer better look what? Exponential. Okay, now to mathematically find the inverse, we have 2 steps. We switch the what? The x's and y's, and then we solve for y. Okay, so let's just do that then. So right now what I have is y equals log base 4 of x. Okay, and if I find the inverse, I'm going to switch the x's and y's. So let's do that next. Then I want it to say y equals instead of x equals, because currently it's solved for x, not solved for y. Okay, so to solve a log, okay, then you're going to turn it into exponential. The base of your log becomes the base of your exponential, or if you like to look at it in circle math, you start with the base, go through the answer, and land here. So 4 to the x power equals y. It's that easy. And looking at number 1, it started as a log, ended exponential. Okay, let's go to number 2. Number 2 is a log. The directions were find the inverse of the function. So currently what I have would be y equals log of x plus 2. Okay, you're going to have to switch x and y and solve for y. It means I'm going to have x equals log y plus 2. Okay, we've not talked about this. This concept is new right now. When there's no base written, does anybody have any idea what the base is? I've got that all day. Makes sense to me that would be 1, but it's not.
0.
Actually. And it's not 0 either.
2, 5.
Logs in base form when they aren't written, it's 10. Okay? So the base of a log in its natural log is 10. Okay, so the base is 10. So you can put a 10 there if you want. That's new, we haven't talked about that. And you're gonna go, we're gonna solve for y. So I want y, which is right here, to be by itself. Okay, so we're gonna turn it into exponential. So start, the base of the log is the base of the exponent. So 10 to the x equals, what's here is y plus 2. But I didn't want y plus 2, I want y, so you have to move the 2 over. So the final answer then would be 10 to the x minus 2. So you went from log to exponential. Now on number 2, number 3, it's labeled wrong. This is actually problem 3. On problem 3, it's in exponential, and I'm asking you to find the inverse. So what do you think your answer is going to look like? A log. Okay, so then let's build this in log form. Okay, but in order to find the inverse, the first step is, currently we have this, so we're going to change it. So you flip your x's and y's, and you solve for y. Okay? If I'm solving, now listen to me for just a second. I'm solving for y, and this time y happens to be an exponent. How do you bring an exponent down? You turn it into log. Okay? I'm going to take, but what is my first step? What do you think? I'm going to move the what? To move the 4 over. And guys, once you move the 4 over, put that in parentheses. Because I'm solving for the y, I want the y to be all by itself, so I'm going to get rid of all the excess. So I'm going to move the 4 over first. The way order of operations. Okay, now then, I just have it in exponential form. You're going to turn it into log. So the base of the exponent becomes the base of the log. Then you're going to write your x plus 4 here equals y. Okay, there's always one that gets a star, today it's number 4. The 4 is kind of hard. Take good notes on it because there's a problem on your homework, just like number 4. Okay, it's an exponential. We're going to find the inverse. So let's flip x's and y's. So this becomes x equals 6 raised to the 3y plus 7 minus 2. Right, so my goal is to solve for the y. Well, y is in an exponent form, so to bring it down, I'm going to turn it into log form. Okay, but first, I've got a bunch of stuff on the right I don't need, so I'm going to move that 2 over to begin with. So this becomes x plus 2 okay, the y is still an exponent. So to bring it down, we're going to do circle math, or in other words, the base of the exponent becomes the base of the log. So log base 6, start at 6, you go through the x plus 2, so you're at x plus 2 next, put it in parentheses, equals all of this on the other side, 3y plus 7. Yeah, it's weird. So now then, what's your next step? You're going to move the 7 over. Okay, so watch this next step. This is going to say log base 6, x plus 2 minus 7 equals 3y. And at this point, you guys are going to want to try to combine the 2 and the 7, but you don't. You guys, you know how when you're trying to graph a quadratic or graph a parabola or anything like that, when something's in the parentheses, it's a shift left and right, and when something's outside of the parentheses, it's up and down. If I combine those, I'm messing it up. Do you see what I'm saying? And it's no different with, it's the same with every graph. Okay, so you can't put them together. It's telling you the nature of the graph. So now then we're going to divide everything by 3. So your final answer then is just y equals log base 6, x plus 2 minus 7, all of it divided by 3. Nice and messy. Good thing the next problem is really easy. Last problem. Okay, number 5 says, look at the graph of an exponential function. It's exponential. What is the x-intercept of its inverse function? What do we know about inverse functions? What happens to their ordered pairs? What are they going to do? Because they're going to flip. Okay, so if you look at the y-intercept, which would be here, what's the name of the y-intercept?
Y equals 1.
It would be 0, 1, right? Agree?
Yes.
That's the y-intercept. Well, the x-intercept is when y is 0. You know what an x-intercept means? I'm looking for the x-intercept. So the ordered pair looks like something 0. That's what an x-intercept point looks like. So if I have 0, 1, okay, then the x-intercept is going to be 1, 0. And you can think about it. This is your imaginary line. I hopped over it perfectly. 1, 0. Okay, now I'm going to pass out your homework.